Hi all, my name is Michel Weststrate, and on Thursday I emailed Madeleine and I asked how much time do I have for a lightning talk, 5 minutes or 10 minutes? And she emailed me back, she said, you have 30 minutes. So that escalated quite quickly. So I will be talking today about MobX. And I'm just wondering, since we have quite a mixed audience, who has heard of MobX? Cool. And who has used it? Awesome, there's a lot to learn. There's a lot you can win. So I will first give a very short primer on what MobX is. It's a state management library, or you could also call it a reactive programming library. And this is roughly what a MobX application looks like. So we start with a very simple to-do application, and we make it more complex later on. But so here's a very simple to-do model class. It's using a decorators, but that's not required. And we simply say that it has two observable attributes, title and finished. And the rest is just a bunch of boilerplate and a very straightforward action that just toggles the state of the to-do. Similar, we have a to-do list, a store that contains to-dos, again observable, but it also has a computed value, a value that is automatically arrived from the to-dos which are in the store. And we don't tell it when they are derived, just that they are. And so next is a React component. It's a stateless function component. And it's very simple. It simply maps over those to-dos, creates a to-do view for each of them, and passes the to-do along. And it also shows you the unfinished amount of to-dos. The to-do view, again, is very similar. Just a stateless function component, renders the to-do, and invokes the toggle action once we click it. And so the rest is basically React boilerplate, like rendering the to-do list into the DOM. And we do this only once. And after that, we initialize the store with some data. And it's like really straightforward, just plain data mutations, as you have doing them for years. Now, of course, I can run this demo. So this is the same thing on a GS bin. Let's make it a bit smaller. So this is basically the same code, the to-do list view, and the to-do view. And what is now nice is that if we click this to-do item, that specific to-do got re-rendered, and also the list got re-rendered because the amount of tasks left changes. However, we didn't declare that anywhere, that there is a re-rendering to be happen. There is no action which is dispatched, none of that at all. It just knows. And to prove that, I can even start changing our store from within the console. And so a new to-do is added. And MobX has figured out that the list needs to be re-rendered and that the new to-do needs to be re-rendered. Similarly, we could just alter one. And so now we see that exactly that to-do is being rendered. We didn't tell it to do, it just happens synchronously right after we enter our command. So this talk will be about how is that possible? Is it magic or something like that? But of course you will be wondering, this is all nice and dandy, but well, it's a to-do list application. Does it have real use? Can we build real things with it? So I work at a company called MobiX, and this is what we built with it. This is an application development studio. And it doesn't fit entirely on the screen now, but in it you can just draw pages and model them. So it's like a WYSIWYG editor where you can configure everything you see. And also there's a data model in that application which can be altered. And this is the data model of a real application, so it's quite complicated. It's freaking large, actually. So the cool thing is that this is entirely powered using MobX. It's completely reactive from the back to the front. And so if we draw it around, we see that not just the entity is moving, but all the arrows are moving with it along. And we could even make the title a bit longer, a bit more. And you see that the arrows move to the right to pick up the remaining space. And the fun part of it is that we didn't write a single line to achieve that. These are just SVG elements, and those are written using those stateless observer components. And we just say for an arrow, hey, the starting point is the center of the entity you're connected to. And then whenever we do something with the entity, MobX knows that the arrows need to be moved along to have a consistent view. But we don't have any on submit action that tells, oh, please now re-render all the entities and re-render all the arrows. And the reason for that is that we simply don't want that because there are way too many entities in here and we don't want to re-render them all of when something changes. We just want to re-render the ones that are connected to this entity. And that is what MobX determines for us. So back to the slides. So, is it magic what is happening here? And this is what a guy recently tweeted about MobX after he started it. And he said basically, you just mark data as observable or reactive, and the rest is magic. So let's talk about this magic. I want to try to answer 3 questions for you. How does transparent reactive programming work? What does it solve? Which is the technique which is behind this? How does MobX know what to do? And why is MobX code so simple and fast? And of course, since this is apparently magic, you know a magician can never reveal a secret. So sadly, I cannot tell you. But maybe I can teach you how you could build this thing yourself. Let's talk about applications. Applications basically do 2 things. They manage state, so that is what your application is about, like sending tweets or entering a form or I don't know what. But your application is somehow about data, about state. The other thing they do is that they transform this state into other things, like a UI or maybe into a JSON request to a server. And so we start explaining this with a very simple example of state, with just 2 variables. Now you probably heard of this equation, which says UI is just a function of the state. And the question is that true? So here we have a React rendering, but it could also be something else, which takes the variables, calls a full name function, and that produces some DOM. And so what we could do if these things are just pure functions is substitute the output of one function into the other function. So we could say that full name in its current state is just concatenation of my name, and that the DOM is just the rendering of that name. Of course, then it immediately becomes clear what is what is the problem when looking at this. I mean, if we just run this function once, this view function, then you get a DOM which is outdated. It doesn't match the state. So when we change the first name into the name of my daughter, then nothing happens to the DOM. So actually we mean something different. Actually we want to have our DOM connected to what is in our state. But what we did is when we call functions is that we just copy values around, but we lose the connection with the original source, the state. So that's what reactive programming is all about restoring that relation. So what we actually kind of mean is that we have not values that are copied around, but expressions that are copied around. Those are often referred to as stunks, which is basically a function that takes no arguments. But it means that if you have a programming statement, you cannot just execute it once, but you can execute it whenever you want, because it's wrapped as a function. So actually we mean something like this. Full name is the first name, Tank, concatenated with the last name Tank, and then we render that function into our DOM. Well, of course, the question is, one cannot simply use Tanks everywhere. I mean, this doesn't work. This code doesn't compile. So this is a hard thing to do. I mean, even if we were able to concatenate two functions and a string and have something meaningful from that, then we still cannot render that function into the DOM. I mean, this, if you would render this, this would print a string inside the div, not or function inside the div, not my full name. And we have a lot of questions to answer when we start passing around Tanks. Like, for example, when should we re-evaluate the full name? For us as humans, it's clear whenever the first name changes or when the last name changes. But how should React know? And when do we need to re-render? And also important, when do we stop calculating these things? So in order to be able to do that, we need to make our state observable so that Tanks can know that the thing they're using has changed. Secondly, we need to be able to track whatever a Tank uses. What values, what state did it use during execution? And thirdly, we need some mechanism to run only these Tanks which are invalidated by our state changes. So in short, we need to observe all the things. Remember this slide? Applications are about managing state and transforming state into something storable or viewable. And that is where MoveX comes into play. What MoveX does is it keeps your transformations you have, which might be your UI or it might be your server request, consistent with your modifications. So it's a tool that allows you to do any transformation with your data and make sure that whenever that source data has changed, the transformation is rerun. And it does do that at all times and with the minimum amount of recomputations possible. So this is what this same listing would look like if you would use MobX. So we turn the two primitives into observables. Some call these box observables or reference objects. And we have this computed thing, which we wrap around the Tank that calculates the full name. We can now access the value with a get, but later you will see you can even get rid of that. And we just say that the rendering needs to be run automatically. We don't say when, we just say that please run this whenever something relevant changes. So there are three functions which are key here. And that is basically the entire core of MobX. Observable, which makes values, objects, arrays, references, whatever you need, observable. Autorun, which basically takes a Tank and runs it when needed. And that is mainly important for producing side effects, like saying, React, please render into the DOM. That's not a pure function, that's a side effect. It doesn't produce a new value, it alters the DOM. And on the other hand, you have computed, which is very similar, also takes a Tank, but it produces values instead. And the nice thing about computed values is that you can't stop computing them when you know for sure that nobody is observing that value. So we don't know when we need to stop rendering the DOM, well, until the user closes his window. But we can know when we need to stop calculating things, and that is when they're not in use by the UI anymore. So let's show that that works. We had these already. So here's exactly the same thing. You just saw my slide. And we can run it. And hopefully I have a network connection. So I now did run my full name. And if I just say first name set Yeah, the auto run has detected that the rendering needs to happen again. And so far, there is nothing React specific in here. This is all just generic MobX code. So that's what MobX does. It did observe full name, and the full name used the first and last name, so start observing that. The first name changes, hence the full name needed to be recomputed, hence the auto run needed to run. So that might feel a bit magical. That was the magic I was talking about. So let's explain how this works by basically re-implementing what MobX does in roughly 50 lines of code. So here's an array. That's where it starts. It's a stack, and this stack is very similar to the function stack, and it contains all the chunks that MobX is currently running, which are being controlled by autorun or computed. Next, let's implement our observable function. As you saw, it takes an initial value, and that value is stored in the local scope. And furthermore, each observable has a list of observers. Nothing exciting. This is also not very exciting. There's a subscribe and an unsubscribe method, which pushes an observer to the observers collection, or removes it. So this is pretty straightforward stuff. Set also isn't very interesting. What it simply updates the value of which is stored in local scope. And then it says to all the observers, please run again. And bear in mind, this is a naive implementation, but it gets the ID clear. So for example, if the full name or the first name is changed and it has an observer, the observer is run again. The get is a bit more interesting. It peeks at the chunk which is on the top of the stack. So that is the innermost chunk which is currently run. And it just says, hey, that chunk, that depends on me because my value is currently being read. And then it returns the value. So, and that is the complete observable function. Next, the autorun, which takes, as said, a chunk. And it also has a collection, namely the observables it is currently observing. And it creates a reaction object. And that object has an add dependency function, which adds an observable to the list of things being observed. So that was the function which was called in the get function of observable. So next there's the run function, and that's the interesting one. And it starts with pushing itself on top of the stack. So this is now the chunk that is being run, which is being tracked. Then it removes unsubscribes from all the things it is currently observing. It runs the chunk, and the original one, and during that run, it might access 1, 0, or more observables. And so these observables end up in the new observing array, and it starts observing all those observables. And after that, it just pops from the stack, and we initially trigger the outrun for the first time by calling run once. And so that's the entire relationship between observables and autorun. And computed, as said, is a bit similar, except that it can return a value, so we can cache that. So we create an observable value, we start with nothing, and then we automatically run the chunk we passed it in. So that whenever the output of that function changed, we can update our cached value and return that. So that's basically the whole core essence of MobX. This is what transparent reactive programming is. So the rest is again from the slides, first name, last name, and this is all unchanged. And I can literally run the file which is behind this slide in my terminal, and we see that it has logged twice because that's what we told it to do in the autorun. And so you see that we first run the autorun, prints my name, and then we change to pieces of state, and we see 2 new console statements without us telling it to do so. Yep, wrong button. So this idea of transparent reactive programming is not entirely new. It's far from new. It's you might know it from spreadsheets. That's, I think, where the idea is born. But tools like Meteor use this, and also Angular and Ember has similar mechanisms. But MobX is actually quite different. And the main difference is that the other libraries don't solve the problem in general, they solve it for rendering. So what they do is, you can imagine that you get a whole bunch of dependencies in your calculations. And what most of them do is that they run some change detection mechanism. And they often do that after all things have happened, which is nice because you only need to flush the DOM now and then. It doesn't have to happen in sync. But in MobiX, everything is run synchronously. Everything, all derivations happen immediately once you change state. And it makes it way easier to debug, because if you are questioning, why is this derivation currently being run, you can simply put a breakpoint in it, and your stack will contain the causing mutation. So you can just follow your stack, and you see what state has changed in order to run your computation. And also, it's far more generally applicable as just in the UI. So as you saw in the code, the dependency tree is dynamic. So that means that I'll show you an example in a minute. That's easier. So it has quite some interesting runtime properties, because these are features which were lacking in other frameworks. So what MobiX does, it analyzes your dependency tree, and I'll show you in a minute how, so that derivations are not run twice accidentally, or that they are not run immediately, and that they don't introduce glitches. And I'll explain that also in a minute. And as said, unobserved computations are suspended. So here's an example of how we could introduce easily a glitch. So here's the same autorun, but a little more complicated. So if the first name equals 42, then we only print universe, but if it has any other value, then we print the full name. So what does this autorun function react to? Well, that depends on the current name of the current value of the first name. Because if the first name is 42, then this reaction would only react to changes in the first name. But if the first name has any other value, then it would also react to changes in the full name, because apparently now the full name is also relevant for render. And how that roughly works. So you can imagine what happens behind the scenes is that there's a dependency tree behind observables and reactions that react to it. So if first name changes, then the full name needs to change, and if the full name and also the outrun needs to change, because outrun checks if its value is 42. And the last name influences the full name. It doesn't influence outrun directly, but full name itself influences the outrun as well. And if the first name is not 42, then the full name is not relevant, so it's no longer being observed. And since full name is not relevant anymore for anything, then also the last name is not needed for anything anymore. That's determined automatically by the 50 lines of code we just wrote. So what happens if we change the first name? How does that propagate to the system? So the first name changes, so the outrun is re-triggered. So we run the outrun. That's what we said in that loop, run all your observers. But also the full name is rerun, because that's another observer of the first name. But because the full name changes, the outrun is triggered again. So we have now one change in the first name, but the outrun has run twice, and one time with an inconsistent value of full name. And as usual, we don't notice that, but that's what in reactive programming is called a glitch. There was an unnecessary run based on inconsistent data of the outrun. So how MobiX solves that is very simply. It gives each tunk, it gives it a dirty value. And once a observable changes, it doesn't run the observers, but it just says, hey, you're dirty. So full name and outrun get a dirty value both of 1. But that is a recursive process. So full name also tells its own observers, hey, you're dirty. So outrun is now double dirty. After that, immediately after that, first name just say, hey, I'm ready again. I have a new stable value. And so it decreases the dirty count of all its observers. So the full name now drops to 0 and the outrun is still at 1. And whenever a tunk drops its dirty count to 0, MobX reruns it. That's basically what happens. So full name now gets to rerun. And after that, it also tells its observers, hey, you're not dirty anymore, I have a stable value. So now the outrun can run. And this way we have eliminated our glitch. So we know for sure that automatically all derivations are run in the right order. And if you're familiar with MobX, even though it's synchronous, you can still batch changes, so you can postpone derivations until the end of the block. And what that simply does is postponing those ready messages. But you will run in that automatically once you start playing with that. So probably now a bit like this. But to answer the original question, is MoveX magic? Is transparent interactive programming magic? No, it isn't. It's just a stack of tunks, a bunch of counters, and 2 collections. And maybe you're thinking, well, all those getters and setters, and it doesn't really like the example you started with. And if you are familiar with MobX, it also doesn't look opinionated MobX or idiomatic MobX. But that is just a few syntactic tricks away. So usually MobX code look more like this. You have a state object, it's observable, and it has some attributes and some computed values. And then there's a React component, and we don't want to always render the whole React tree. That's expensive. Now we mark individual components with observer, which makes sure that they render in time. And what observer does behind the scenes is roughly this. Whenever a component is mounted, it simply wraps its render function in autorun. So now whenever render accesses some data, MobX knows that whenever this data changes, that component, and exactly that component, has to be changed. So that means that components can now render independently of the parent. It doesn't require the whole top of the tree to be re-rendered, but it can re-render exactly the right moment. That's what you saw in the demo earlier. And whenever that same component gets unmounted, we simply stop the autorun. That might clean up some computed values which are no longer needed. And that's basically it. And as you can imagine, this pattern is so simple, you can also apply it to other frameworks. And I know that people have been doing this for Angular 1 as well, for Jojo, jQuery, Deku, or just raw HTML rendering. Then again, how does these observable objects work? Because you now see that we no longer invoke get functions, we just directly access the attributes. And also we can simply assign new values to the attributes, and still MobX knows what needs to happen. Well, that's actually pretty simple. Observable is just a shorthand for extend observable. And extend observable takes 2 objects, and for each key value pair in the source object, it introduces a new property on the target object. But also for each value in the source object, it creates a new observable. And if you remember that those observables have a get, a met, get, and set property. And from there on, we can just use ES5 properties and simply pass that setter onto the set and the getter onto the get. And then we have lost all these weird get set calls, and we can just do direct object property reads and writes. So that means that it doesn't only work for plain objects. We can also use this in constructor functions, where you just say, please extend this object with these observable values. And if you're into ESNext and decorators, these decorators are simply syntactic sugar to the previous constructor call you saw. So we can just define this attribute is observable, that getter property is computed, and you can build persons and still read and write values directly to it, and everything that needs to react will react. So far you might have noticed that I didn't really talk about change detection. And that is basically because MoveX doesn't need change detection, because observables will themselves will tell the system, hey, I have changed. This attribute of mine has changed. Those things, please figure out which things need to re-render. So there's no change detection mechanism, no change detection loop. So that means that if you make changes asynchronous, like I did in console, just at some arbitrary moment I start typing into the console and make change to the state, that works out of the box. Nothing special needs to happen, because there's no change detection loop which needs to be run. So hopefully you're now like a, whoa. And so what about immutables? People tend to tell nowadays that you need immutables if you want performance. So actually the truth is this performance-wise. Immutable objects are faster if you want the best performance React than mutable objects. But with observables, you get even better performance. And in my talk in Amsterdam, you will see some metrics from that and why that is. But the idea behind that is, and this surprises people often a lot, that MobX implements should component update, and it does so by using the pure render mixin, by using pointer equality. And you might be thinking, but pointer equality makes only sense when I use immutable objects. Well, I think I just leave you with this question, because if you figure out why you can use pointer equality on mutable objects and still have everything reacting and rendering as efficiently as possible, then I for sure you have know for sure that you have truly understood MobX. So from now on, you're a wizard, enchant your PM, just use MoveX, because you will see a lot of magic happening. You can find a lot of useful tutorials, resources, boilerplate projects on the GitHub page. There's an Egghead course coming soon. We're just wrapping that up. And you can follow me on Twitter if you like. Thanks.